Hi guys, and welcome to the next lesson on writing ionic formulae. So we've already talked about under Unit 1, Area of Study 1C.1, common properties of ionic compounds, and we're going to talk about how they're formed and how they're bonded together, as well as how we write the chemical formulae for ionic compounds. So by the end of today's lesson, you should be able to do that. So when a metal reacts with a non-metal, it forms an ionic compound. We already discussed that last lesson. The metal will lose electrons. This is just a summary of what we did. Metal will lose electrons to become cations, and non-metals will gain electrons to become anions. When they lose the electron, they become positively charged. When they gain the electron, they become negatively charged. So here's the positively charged cation there, having lost an electron, and here's the negatively charged anion, having gained an electron. They'll lose and gain their electrons according to the octet rule, where they always want to have a full outer shell. So here we have the formation of electrons transfers and how this determines or how this works out the charges we have. So when sodium reacts with chlorine, it'll lose an electron, we've already discussed that, and chlorine will gain an electron. Sodium is more stable, with having lost that one electron on the outer shell to become 2A. Chlorine is more stable, having gained that electron on the outer shell to become from 287 to 288. When we draw these electron transfer diagrams, you need to have balanced number of electrons being donated by the metal or cation and accepted by the non-metal anion. For example, let's try magnesium and oxygen. So magnesium has 2 in its outer shell, which means it's got 2 valence electrons, which means it'll want to lose those because it has less than 4 electrons in its outer shell. So it'll become a +2 charge when it loses those 2 electrons. Now, it can't lose one electron, it has to lose both of them. So it needs something that will accept both those electrons. So oxygen is perfect. Oxygen has 6 electrons in its outer shell, but it wants to gain 2. So it's want to gain 2 electrons, where this wants to lose 2 electrons. So it'll become positive, it'll become negative. The 2 electrons will go to oxygen, magnesium will become 2+, with an 8 on its outside, and oxygen will become 2- with 8 outermost electrons. Periodic table can also be used to help us work out the charge, as we've already discussed before. In group 1, you have a +1 charge. Group 2, +2 charge. Group 13, you're going to have +3 charge in terms of how many electrons is in its outer shell and its valency. In group 4, it can choose to gain or lose an electron. In group 5, it's going to want to gain 3 electrons. It's going to be 3-. In group 6, it's going to gain 2 electrons. It will become 2-. In group 7, it'll want to gain 1 electron. Again, this is shown by this table here, the charges that these ions will form. So you can see that now lithium has a +1 charge and fluorine has a -1 charge. So lithium would have to have lost 1 electron and fluorine would have to have gained 1. So this would be a perfect pair. Lithium would have paired or could have paired with fluorine because it would have lost 1 electron and fluorine would have gained 1. Whereas if you would have had sodium, it could pair with oxygen, but since oxygen has to gain 2 electrons and sodium only loses 1, you would need 2 sodiums to satisfy the 2 electrons that would oxygen requires. So using the periodic table, you can see how these compounds would match and how they would combine, but you need to make sure that the electrons that you lose are the same amount that you gain on the other compound. So the metal must have the same number of electrons lost as gained by the non-metal. And this is how the periodic table can be quite useful in working out the ratios in which things would bond. So ionic compounds are formed by the transfer of electrons from a metal cation to a non-metal anion, and the transfer must be in equal proportions and charge between them must be balanced. Anions and cations can be found on the periodic table based on their group number. And today's questions I'd like you to complete are 1 to 5 of chapter review 4.3 on page 98. Thanks.